I know there's many of you that have felt deep despair just as I have when it comes to thinking about setting up inputs and using the new input system in Unity. And people have said to me, well, it's not the new input system anymore, so there's no other good name to give it, so I'm just going to call it the new input system for the basis of this. And I've worked countless hours putting this tutorial together, and do be sure to comment down below if you have any thoughts or improvements on this, because you can share it with everybody else and make sure they get the best details possible, because you can program this UI system in so many different ways. Just because I show you it this way doesn't mean you can't do it in 10 other ways too. Leave a like because it really helps me out, and do subscribe to me, SpeedTutor, if you find this helpful. I'm going to show you a basic reference to looking at the old system against the new system. I'm going to show you how to install it, how to set up your first control map with all your actions, writing your own manager script, writing your own 3D and 2D controller, taking into account dead zones and how to stop your character from moving even if you're not touching the stick, how to invert controls through a processor through code, scaling sensitivity, so you've got mouse and gamepad which share the same sensitivity, how to check when devices are connected and how to know when one's been lost and been reconnected, and then looking at how to navigate UIs, looking at how to rebind controls, and looking at all the sample assets and everything Unity give you, and various other controllers which would be helpful to you. And I'll leave loads of annotations in the timeline so you can skip along, and I'll put it down in the description with all the resources that I've got for this video too. And do be sure to check out my Patreon to get access to all these scripts, this entire project, and everything you'll need. And Unity currently have their Unity Awards sale on at the very minute, and I'll put all the links below. Now, this is a really simple reference when we look at the old input system against the new input system, is that the way that we do basic button presses. Let's say we used get key down. But when we know that usually in the old input system, if we press the spacebar and we use get key down, it's when the spacebar is pressed down, we make an action happen. That's great for the vast majority of button actions that you do. And in the old system, to say do sprinting, we use get key, and that just understands when we're holding the key down, we make an action happen. But how do we translate this to the new system? If you just want to use get key down, you can make sure that you've referenced the input action that you want to use, which in my case, I've got an input action called jump action. And I make sure at the start method, I find that in the player controls, I find the map, and I find the action that I want to use. Now, I can do something as simple as jump action dot triggered. That means if I've pressed the button, I must have triggered this button to press, and away we go. Now for get key, we make sure that we also have the action that we want, so an input action, which in this case could be sprint action. We make sure that we found it in the action map and found the action. So if it's anything above 0, we must be holding the button down because the Unity input system recognizes it. Sprint action dot read value, and then in angle brackets float, then just 2 brackets at the end. And if it's greater than 0, then we can make our action happen. So first of all, I'm going to show you how to install the newer input system, and I am using the newest version at this current time, which is Unity 2022.3.16, and I'm using Unity URP, and it does work across most other pipelines and previous versions too. Go to Window, Package Manager, and once Package Manager is open, you can navigate to the top corner, go to Unity Registry, and just type in on the top right that you want input, and you will get the input system, and mine is a version 1.7 at the very moment. Doesn't matter if it's newer or older. Then you want to click install, and it will bring up this error message which will tell you that you need to restart the Unity editor to make this work. And this is also important if you install assets from the Unity Asset Store. You may need to restart your editor to make the new input system take effect. So just hit yes to restart Unity. Now, if you want to change between the new input, the old input, or use both, you can go to Edit, Project Settings, and if you go to Player and then scroll on down to where it says in Configuration, and it shows Active Input Handling, you could choose whether you want to use a new one explicitly, the old, or you can use both. I like to use both in case I want to use the old input system just to make some quick inputs for debugging. And I just wanted to say, before we start creating our player actions map, this could be useful for other people too. On your binding of your action that you've created, when you want to choose the path to choose what type of control you have, if this is broken and you can't listen for input or the navigation is looking weird and it's just not working correctly. In the dark theme, it can't find a particular toolbar. Now, I did some Googling and I found a fix for this, thankful for all the people on the Unity forums, because for some reason, Unity hadn't fixed this simple issue. There is one letter of a spelling mistake deep in the Unity files that you need to fix. So if you navigate to C, users, your computer name, app data, local, Unity, cache, packages, packages.unity.com, com.unity input system at whatever version you're using, input system, editor, internal, advanced dropdown, and open the advanced dropdown GUI. I know that was a hell of a lot to take in, but once you navigate to the advanced dropdown GUI, you can open that up in any editing program you have. You can open it in Notepad, whatever you want, Visual Studio, and here, search will be spelled without an R, so make sure you add an R in there. Save that file, and then if it's not reflected or changed in your editor, make sure to navigate to the root of your project and delete the library folder, then open your project again and it'll rebuild the entire folder and it should be fixed and you should be able to listen for the controls and it will make your life so much easier. So now we're going to create an input map to control all of the actions that our game will use. I'm going to right click the project panel, go create and choose input actions at the very bottom, and I'm just going to name this to player controls. Double click that to open out the editor and you'll have three sections, one which is action maps, one which is actions, and then the settings for the actions that you have. Now action maps are just names of groups of actions, so you could have for UI, you could have for vehicles, you could have for multiple players. So I'm just going to name this one to my player. And these are all going to be my player particular actions. So what I'm going to have for player actions is I'm going to have move, look, jump, and sprint. So it gives you some ideas on movement to be able to do basic interaction on a button press and sprinting to be able to hold a button. So these are probably the most use cases you're going to have with an input system. So of our actions, we've already got an action. We can rename that to move because we're going to specify that in code later. So it's good to give it a name which you're going to be able to refer back to and remember. And then on the right side, you've got the action type. So you've got pass-through, button, or value. Now for a move, it's going to be a value because you can move in multiple directions, left, right, up, and down. So you want to make sure that it's a value. And then you want to make sure that it's a vector too, because in vector 2, you can move left and right, and you can move up and down. You don't move it in the y-axis because most likely you're not going to be doing something like flying. So we don't need to worry about that. And then from there, we have bindings. And if you need to add new bindings, you can click the little plus and click add a binding. Now the binding is something where we can attach a control scheme to it. So say we want something on your gamepad or something from your keyboard. Now on the binding here, what I'm going to set, I want something on my gamepad. In this case, I'll cycle to gamepad and I'll probably want this as my left stick because that's going to be the default action in most games to move around. Now we might want to use something on the keyboard, so WASD type of scenario. Now you can click on the add a new binding and you can add an up, down, left, right composite. And that just means that it's created a vector 2 for up, down, left and right. So as you can imagine, up on the keyboard is W. So you can see W keyboard. We can select down, and when we search in S and left, and of course you can listen and you can press the key. And I've searched for A, and then right will be D, so I can do listen and D. So there'll be the bindings for that, and you can obviously add more if you want. But what we're going to do is I'm just going to duplicate move because it's very similar for look. So this one's going to be our look action. It's going to be a value in vector 2. But in this case, it's not going to be a left stick anymore. It's going to be a right stick. And then this time, it's not going to be a vector 2. We're going to add a new component, which is just a generic binding, and I'm just going to search for mouse, and it'll be mouse delta, so it's at the position of the mouse at any time. So this is it for two actions, which have multiple values depending on where we're looking. Now one which is just two buttons, so in this case, I'm just going to set a new action as jump by clicking the little plus in the corner to create it. Then my binding will be on my gamepad. We can have button south, which will be using A or X on the respective gamepads. Then we can add a new binding, which in this case, keyboard, usually the spacebar, which is nice and perfect. And remember that the action type can be just left on button because it's something that we only want to usually do once, or when we're actually pressing it, it'll only have one action. Then we'll click another one for the sprint. Sprint is exactly the same. It's still a button, The binding is going to be whatever you want, and I will usually use the left shoulder on a gamepad. I'm going to listen to, and I'm going to press left shift. Or you can have shift just generically on your keyboard if you want to use all shift keys to take it into account. I'll keep it as left shift for this because I only want it to that side of the keyboard. And then one thing to mention when you do this, it's good to have autosave enabled. So when you make changes in here, it will be automatically saved, so you don't have to then close it and save it out. It will just, so you don't forget. It's a big thing to remember actually, because some of the times I was making some edits and I didn't save it, and I was thinking, why is this not reflecting in my game? Because autosave wasn't enabled. And of course, if you close this and you hadn't saved it, it would ask you to save it because it's just a prefab in itself. So now we've created our set of actions, we're going to create ourselves a manager script, which is a way to centralize the control of all our different inputs. So we never need to sort of do long references in code anymore. We're going to control it in our manager, and then we can do shorthand, nice easy references within our scripts, and we can use these across multiple scripts as well. So we'll right click in the project panel, go create, and I'm going to choose a new C# script, and I'm going to call this my player input handler. I'm going to open that up in Visual Studio. We need to make sure that we're using Unity engine.input system. So I'm going to start off as a header, and I'm just going to create and make this nice because this will be all up on my Patreon to get all the projects and all the scripts, just so that you never miss anything out. But we're going to keep this nice and neat so we can keep it organized. So I'm going to have square brackets, serialized field, private, and I'm going to call this an input action asset. And we're just going to call this our player controls. So that's the input action asset we just created with all those actions. And what I like to do to make things easier is to create a reference to the action map. You know, so the action map could be if we wanted to control a vehicle, player 1, player 2 being able to fly, whether it was UIs, remember when I talked about it? But in this case, I'm going to write square brackets serialized field and say private string, and we're going to call this the action map name, and we're going to set that equal to player, because you saw that in our action maps here, and we name this player. I'm going to create string references to the names of each of my actions, just so that we can edit this in the inspector if we need to update it more easily in the future. You don't have to do this, but I like to do it just to make it nice and easy for you to read, and if anybody else comes to read it, it's nice to use. So we're going to say private string move equals, in quotes, move, or whatever you named your action. Again, we're going to have private string look, set that equal to look, in quotes, and these other two are just jump and sprint. And now we need to actually reference our input actions that we're going to find at the start, just so that we'll be able to use them in script. So we're going to write private input action, and we're just going to name this my move action. New input action as the look action, and nicely Visual Studio knows what I want. So I want the input action for the jump action and the sprint action. And these are all private references to those. So I'm going to create some properties now for the value of each of our actions that when we create them. So we'll know when something is pressed, your controller is moved and what direction it's moved in, or if we're sprinting and it equals a specific value. And this is instead of just doing a public reference to the thing, we'd use a getter and setter to make it more protected to be able to nicely use it within script. So in case for our moving action, we want to set this as a vector 2, and I'm just going to call this move input. Then what I'm going to do in curly brackets is write get colon and then just have a private set. And I'm just going to copy that line. I'm going to paste 3 below and then have this one set as a vector 2 and my look input. Then I'm going to have, instead of a vector 2, I'll have it as a bool for whether my jump is triggered or not. And then in this case, we're going to have a float value to be able to tell whether we're sprinting. And now mentioned in the reference that Boolean is true or false, and the sprinting is it greater than a particular value. Now I want to use this script as an instance or a singleton, so I'll be able to reference this from other scripts nice and easily, and it'll be the only one that exists in my game. So I'm going to make sure public static, and I'm going to reference the script name, have it as capital instance, and have this as a get set again. Then we're going to have void awake. So in my awake method, we need to make sure that we actually set this instance to make sure that we can't have duplicates of it at any time. So I'm going to say that if the instance is equal to null, then we'll say instance is equal to this, so we can only use one. Then we'll use don't destroy on load game object, which means that it won't destroy this object if this already exists. And if in any other case that it doesn't exist, we'll make sure that we'll destroy the game object in case it makes a copy of this script again, because we only want one to ever exist. Now, still within our wake method, we need to be able to reference our actions and find them exactly where they are, because we need to be able to use them. So we'll say move action equals the player controls dot find action map, and then in brackets, instead in actually specifying the string name, I don't like to do that. So I like to make it easier because we created the action map name, and then we'll find the action in there, and then in brackets, instead of specifying in quotes, we can just write the name that we'd already created, which was move, as it above is the action map name, move, and we found that action that we want to be able to use. And obviously we need 3 more, and as you can imagine, look action equals player controls, then we find the action map and we find the action of look, and then as I say, in here we can specify the names if they ever change in the inspector without having to run into our code, into our manager, to be able to change this. Then a really important thing to do is use on enable and on disable, because when we're using this input system, it uses events, so we want to enable and disable events when we don't need them. So we can reference every single action and make sure that we use the action.enable in all of these cases. And as you can imagine, on disable, we need to make sure that every action disables when the game ends or the script, or we move to another scene if we get rid of this script. We need to be able to register these actions that when they happen, we need to be able to read the values in them. So to keep this nicely organized in our wake method, I'm going to create a new method called register input actions. So just below here, I'm going to void register input actions, just like that, because something needs to happen. These need to happen in a wake to be able to register the actions. So we're going to say move action dot performed plus equals context equals greater than the move input equals context dot read value in square brackets vector2, and then add brackets on the end and a semicolon. So this just means we're looking for whether the action is performed anytime. We're just giving it an intermediary method, and we're looking at the move input, which is a vector2. We're reading the value at that time when we're looking for it, and then we know exactly where it's going to be. And with this, you have a performed action and you have a cancelled action. In the cancelled section, so we have the move action dot cancelled plus equals the context, and then equals greater than move input equals vector2 dot 0, because in the cancelled it shouldn't be doing anything. We shouldn't be moving because we're not pressing a key, so nothing should be happening. And we'll do this extremely similarly with the look action. So the look action dot performed, we've got the context, we're looking for the look input, and then we're going to read the value, and when we're cancelling and we're not doing it, there's nothing to happen. And then in an example, if we're doing a boolean like just a get key down, then we have the jump action dot performed. We've got the context. We're looking for jump trigger, but in this case it was a boolean, and all we need to do this time is it was set to true if it's performed, because we're just pressing the button down once, and if it's cancelled, it will be false and we won't be pressing a key, so we shouldn't be doing anything. And then in the case of our sprinting, we're looking that if it's performed, we're looking at the sprint value, and we're just using the context read value, and instead of vector2, we're reading the float because that was the property type. And then if it's not doing anything, sprint value would equal to 0. So it just means that the button wouldn't be pressed. It wouldn't have any value. So with this now nicely set up, we can reference these inputs by just using any of these here, whether we want to reference the sprint value, whether we want to see if the jump's triggered, whether we want to use the look input or the move input to see what position the character is in at any point. We can use this. And of course, if you add any other actions, you can add a new string, you can add a new input action, you can check or create a new property to be able to look at what value that needs. Then you can find the action that you need, the action map with the action, make sure you register that action with whatever you need, and then being able to make sure that you enable and disable that action. And once we've got this set up, we've done all the legwork with setting up all of our actions. So now with all our input controls set up and the input handler manager script created, we're going to look at creating our own first-person controller. From the start, I've just got a empty game object, and this has just got a character controller object on it. So you can go to add component and make sure you add character controller. And with the character controller on, you will see it has its own collider. This is just a built-in component by Unity which lets us set the height and slope amounts and have some built-in functions so we can create our own first-person controller. I've got a main camera attached to that first-person controller, which is just on top, and of course I will have this all on my Patreon for you to get hold of it so you don't have to create it yourself if you don't want. I do have a more complex version on my channel which is about adding footsteps and things, but we won't add that today. We'll just add the basic components to a first-person controller. So I'm going to create a new script by right-clicking, going create and choosing C#, and then I'm opening the script called FPSController, of which I've just named it. I'm going to add a header which is just for my movement speeds, and then I'm going to have serialized field private float walk speed, set that equal to 3.0f. Then I'm going to have one called float sprint multiplier, so I'm going to set that to 2 at the start, and this is going to be that when we start sprinting we're going to move twice as fast. Then I'm going to have some jump parameters, which is just 2 floats for the jump force, which I'll set to 5, and the gravity, and normal gravity has a value on Earth of 9.81. Then I'm going to have 2 floats for my mouse sensitivity and the range of which we can look up and down, so we might want to limit that so we can't look all the way around and break the game. Then we'll start by writing an awake method, and we want to find our character controller. This is the thing that we're going to use to force us to move the character rather than using a rigid body or anything like that. So we need to create a private reference to the character controller component. I'm going to have that as lowercase character controller. So we're going to have the lowercase character controller is equal to get component. Then we're going to look and find the main camera because we're going to be able to move this when we come and do our mouse rotation. So we'll say private camera and call this main camera. So we're going to make sure that we create or find our main camera. So we'll say main camera equals camera.main. Then we're going to have another field, which is just the input handler for the input handling. And we're going to set it equal to input handler equal to the player input handler.instance, which is the object that we created, which would exist only once in our scene. Then we're going to have ourselves an update method. And within this method, I'm going to have 2 methods which control our movement and our rotation as 2 separate things, so we can keep this nice and organized. So now we'll have a method called handle movement. So first of all, I want to show you how to use the input for doing sprinting, or to be able to detect that key that you hold down. So we're going to calculate our speed based on what our walking speed is and then timesing it if we're sprinting. So I'll say for this time is I'm going to create a local variable called speed and then set that equal to walk speed times by the input handler that we've created the reference for dot sprint value, so that value of whatever the key was at any time. If it's greater than 0 at any point, we must be pressing that key down, question mark, sprint multiplier, and then colon, I'll just say 1f. Then because the question mark just means that if it is above the value, we must be sprinting. If not, it's just going to be a value of 1. So walk speed at its normal is times by 1, so anything times by 1 is the same. And the sprint modifier by default is 2, so it will double our walk speed. Now I want to get the direction that we're looking at in local space because it's where our character will be looking. And then we need to transfer that to world space. So I'm going to create a vector 3, have this as our input direction, and have that equal to new vector 3. Then open up brackets and say that input handler dot move input dot x, 0f, input handler dot move input dot y. So we've got x, y, and z. So we're moving in the x direction here. We're not moving up and down in the y, and we use the y value because that's just how vector 2 works in this, but it's translating to the z. And then we create another vector 2 to transfer this from local to world space. So we'll say that our world direction, just so we can use it in game, we'll say transform direction, which is a method built in, which allows us, as it suggests, to transform from local to world space and input our input direction. Then it's good to normalize that. If we're pressing one key, we move a certain speed, but sometimes if values go above accidentally, let's say you press W and A at the same time, sometimes we might be able to move faster than we mean, but we need to normalize the value so they never go above 1. So we can then say that our world direction dot normalize. So this is just a method which will do that for us without us doing any extra calculations. It will just make sure that it's limited. So now we need to take the movement directions and apply our movement speed to make sure that we can actually move. So I'm going to create a local variable at the top, and it's called private vector3, and just have this as current movement. Because we may need to use this in other places, we'll go back down into our handle movement method and say that current movement dot x is equal to world direction dot x times by our speed, and then the current movement dot z is equal to the world direction dot z times by the speed. So we're always moving in the x and the z axis because we never need to move up and down because we're not doing anything like flying. Then I might want something to handle our jumping, which we will do a little bit after. And then under there, we need to translate that to fully moving our player controller. And we can use in character controller that we referenced above, dot move, and then in brackets, our current movement is to move that character controller with the built-in method that Unity's character controller component has. And we'll times that by time dot delta time. So we move that in real time. So if I want to give you an example of handling the jumping, so we can just call this method handle jumping. And then in this case, if character controller dot is grounded, and this is good because it's a built-in component into the character controller, so we can see if we're on the floor or colliding with anything, then we'll say that current movement dot y is equal to minus 0.5 f. And then we'll want to say that if input handler dot jump triggered, so if we've ever pressed the jump key, we'll say that our current movement dot y is equal to the jump force. And then if anything else underneath that, whether it's grounded or not, we'll say that our current movement dot y minus equals the gravity times by time dot delta time. So which this means is if we're not grounded at any point, we must be in the air. And so we want to bring the character back down to the ground where it should be. Now we'll create a method to handle our rotation. We'll create a private field, which is just called mouse x rotation. Set that equal to the input handler dot look input dot x times by our mouse sensitivity. And then we'll say that transform dot rotate, open brackets 0, comma, mouse x rotation, comma 0. This just means that it'll rotate based on the x position of the mouse, based on the look position times by the sensitivity, so we can make that happen. So then we need to be able to set our vertical rotation and be able to limit that too. So we want to go back to the top, want to create a new field here, and say that private float vertical rotation. We'll scroll right back down, and we'll say that our vertical rotation minus equals the input handler dot look input dot y times by the mouse sensitivity in this case. And then we'll say that our vertical rotation equals math f dot clamp, open brackets, the vertical rotation, comma, minus up down range, comma, up down range, and end that. So we'll make sure that the vertical rotation never goes above or below that 80 degrees that we'd set, so we can never go upside down or something like that. Main camera dot transform dot local rotation equals quaternion dot Euler, open brackets, vertical rotation, comma 0, comma 0. So then we can make sure we save that out. So as you can see here, I've got my FPS controller with the character controller component on it. We can add our FPS controller script, and you can see that we've got all our variables set up. But on our main camera, you need to make sure that you have got a tag of main camera, because that's what we're going to need to use. And we also need to add our manager or our input handler that was going to manage all the inputs. So we'll just create a new empty game object. I'll reset by right-clicking the transform and clicking reset, and then just renaming this to our player input handler, because this is the only one that we're ever going to have. So we'll add it to our scene, and you can see that it's looking for the player controls asset, which we can just drag in. You can make sure that it's got the correct name of player and all your different actions. You can see I'm moving around and walking with my mouse, and I can switch to my controller, and you can see that I can move much more smoothly with the controller, and I can walk around with the left stick. I can press X to jump and the left shoulder to sprint and still jump around, move around. But you'll see that sometimes we are a little bit slidey using the controller like that, but we can set the dead zones on these, and I'll show you how to do that. Compare the sensitivity of my mouse when I look around. This is just me being really soft with the mouse, and then me looking around as quickly as I can with the controller. They're not the same, so we'll look at scaling these so they are the same in either case as I'm sliding around this scene. So first of all, I'm going to show you how to stop that sliding movement when you might have a controller which could be older like mine. Mine's an older Xbox 360 wired controller. Now, set it on your movement and on your look. These are the two things that are causing that issue. And say I want to add dead zones to my actions, which are the things that might move my controller sticks. So I can apply the processor overall to both actions or all bindings underneath, but I might want to just select my left stick, which is for my move, click on add to add a processor and add stick dead zone. Now from there I can remove the default because the default was too low for me. I'm going to have it about 0.2, something around that value. You can see now I can still walk around with my mouse and keyboard just fine, and now I can walk around with my gamepad and I can move even my left analog stick a tiny bit and I'm not now sliding in any direction. So now we get a much more even character controller which doesn't move around, and this can be different based on the different types of controllers you use, and you can set this too. And again, if you need to set this for say your mouse look, which has a slight deviation on mine, you could set the processor on the right stick. You want to keep this as close to that minimum value as possible without getting an issue, but you lose some semblance of sensitivity if you're not careful. Now you might ask me, how do we adjust the dead zone sensitivity in code? Now I'm going to give you a really quick example in the player input handler, and we'll just put this in the awake method just so that you can see it happen as soon as the game starts. We'll do input system dot settings dot default dead zone min, and then equals to whatever you want your new value. So you could create a field at the top. So in this case, I've just created a new float, which is the left stick dead zone value. And then if we go back down to input settings dot settings, default dead zone value equals our left stick dead zone value. And now on our input handler, we could set that to, in this case, 0.3 because it was different to what I have. If I open my player controls again, go to my left stick and you can watch the dead zone min here. Now you can see my dead zone that when I press play, when I don't have the default ticked, you can see that the dead zone never changes. Now if I leave default ticked and then I press play, you can see that the default dead zone does change that default value. And this is actually the easiest way to change that dead zone if you're leaving the default value as it is and want to change this in, say, like some settings. Now I said I'd show you how to limit the sensitivity between the mouse and the gamepad. So we can select on either of the bindings. We'll start with the right stick. I'll add a new processor and choose scale vector 2. Now I'm going to scale this X and Y by about 2. Then I'm going to look at the mouse delta and also set a scale. And I'll set this to maybe 0.3 on both of the axes because you want to test this out and see what works for you. Because remember, on our FPS controller, we can set the sensitivity. This is classed as mouse sensitivity, but it's just generic sensitivity. So you can adjust that between the two, but you want these to be as close as possible. So when I'm moving with my mouse, it's looking less crazy. And then if I grab my controller and move around, we've got a very similar looking combination between scaling these two things. And of course, you could adjust the sensitivity so they're both not as crazy, or create yourself a menu which just adjusts this value so you don't ever have to adjust the processor at all. The processor is just to scale the two. I said that I'd show you how to do inverting, and now there's two ways to do inverting. One which we just adjust the FPS controller, and one which we can do in the processor. Now with the processor, it doesn't allow us to change this at runtime, so it's not always the best way, but if you wanted it by default, you could either select your bindings for looking or apply this to the entire action itself. So for look, we can add a new processor and choose the invert vector 2. So I don't want to invert the X, I'll invert the Y. Now when I play, you can see up is down and down is up, and I'll do it with the controller. So up is down and down is up, just to confuse things. Maybe if you're wanting to create accessibility or say a flight simulator, but I would say that's not the best way, and we can do this in code. So I'll show you it in the FPS controller because this should only be specific to your character itself. Create another serialized field, which is invert Y axis, and set that equal to false because this is just going to be a camera setting that we might want to use. We'll scroll down to handling our rotation. And at this point here, we need to take into account on what our invert is going to look at. So we'll create a local variable here. We'll call this mouse Y input. Set that equal to the invert Y axis, have a question mark, And then I'm going to say that our input handler dot look input dot y colon, and we'll do the same again for the other side and add a semicolon in the end. But in this case, it will look at y input both of the same value, but actually, we need to add a minus between the look value to do in negative values. Now, in the bottom bit here where we handle the vertical rotation, and we were looking at the y input, we've already found this. Like if you see here, it's exactly the same piece of code. Is just comment that out. We'll say the vertical rotation minus equals the mouse y input, because we found that local variable, and then times that by our mouse sensitivity. So it'll either be the minus value or the positive value, depending on our boolean. So you can see here that I've got camera settings, and I can say, yes, I want to invert my control. And you can see now down is up and up is down. You could adjust the X, but I don't think that's quite as common. Now, if I untick the invert Y, you can see that now up is up and down is down as it was normally. You can keep this to your controller, so you could set this in a settings menu or something. And I have a full tutorial on creating a settings menu, so it might be something that really helps you out for that. And I'll put the link down below to that too. I wanted to show you how to quickly print out a list of all the devices that you have connected, and to be able to understand that when a device becomes disconnected, what you can actually do about it. So let me create a new method in our wake method, and this is just going to be called print devices. This is going to be inside the player input handler for each. So we're going to create a for each loop. I'm just going to press tab to create that for me, but I'm going to write variable device, because this is going to be inside the input system. Then we're going to say in input system dot devices, because this will look through all the devices that are currently registered. And then we'll say that if device dot enabled, so if the device is available, we'll say debug.log active device in quotes, and then add a space, and I'll put plus device dot name. In the start, we expect to see a log of all the devices that are registered. So now you see it when I've pressed play here. You can see that active device is keyboard, mouse, and X input controller for Windows, which is all the devices. As I said, I had a controller, a mouse, and a keyboard. And it's perfect for sometimes you might need to check if they're actually around. Now I'm going to give you the example of how you can detect when a device has been disconnected or reconnected, and then show a pop-up or something like that in your game to make sure that sometimes if you're developing for console, you need to know when something on your controller is disconnected. So I will add this to my input handler, and we need to do this in the on enable and disable, and we need to subscribe to some events. So we can use input system dot on device change, and then plus equals the on device change method, which the difference is one's lowercase, and this is just the method that we're going to specify. And then on disable, I'm going to copy and paste it in, and it'll be exactly the same, except it'll be minus equals, because we want to unsubscribe from the event when we don't need it anymore. So we'll create ourselves a new method to be able to detect this. So we'll say private void on device change, and then we're going to write some parameters to take into account exactly what we need. Look for an input device, call that device, then have the input device change and have that as change. And then we're going to write in here a switch statement, but instead of detecting the device in the switch statement, we're going to actually just look for change. And then in the case here, the first case, we'll say the input device change dot disconnected, and there's a load of different ones. If it's disabled, if it's enabled, reconnected, configuration changed, there's lots of different ones, but the most common ones are disconnected, in case you need to pop up a message to say it has gone or you need to pause your game. Then we'll add a debug log, which says that the device is disconnected, and then we'll add the device plus name, just like we did before, and then we'll add a break. And then in here, we can add some code to handle disconnection. You can pause the game here and bring up a pop-up on the screen. Or in our next case, we need to say the input device change dot reconnected. We can write almost the same debug line and statement below, say that the device is reconnected. I'm going to make sure that I don't print all my devices now. So now I'll press play, and I'm just going to unplug my controller. And you can see there that my controller has been disconnected because it says controller, Xbox controller is now gone. So like I said, I could pop up something in the corner to say that it's disconnected. And I just plug that controller back in, and you can see that reconnected is my Xbox controller. So say that's reconnected, we can then play, get rid of the pop-up, and resume the game again. And for this part of the tutorial, I'm just going to use the 2D simple character swordsman, which does already have its own character controller set up, but it's just literally a base. I'm going to remove all the scripts and we'll write it ourselves to create the basic input and actions that we need. Now I'm going to give you a smaller example of how to set up your own 2D controller and use inputs with that as another example of how to use the input system, because I know a lot of people will want to use 2D as well. Because we'd already set up our player controls for a 3D character, and please refer back to that if you want more details about it, but what I'm going to do is I'm just going to right click my action map for player, duplicate that, and I'm just literally going to call this my 2D player, because you can have multiple, like I said. Now 2D player looks almost the same, but in our case we don't need look anymore, because we only need to go left and right and probably jump, because most 2D games are just side scrolling. So on the move, we can still use the left stick, and we can still use the 2D vector, and it still has an action type of value, and it's a vector 2. But on the vector 2, we don't need W to move up because we'll be jumping, so we can just delete that. We don't need S because we're most likely not going down, so we actually only need A and D now, because A and D would be left and right. Jump would still be spacebar, and sprint you could still have it with the exact same things with the left shoulder button and the left shift. So it's the exact same setup as what we had before. And for those that might be looking at just this 2D player for the first time, I'll quickly run through the overall bindings just so that you make sure that you'll have everything. So I've got an action, and if you need to add an action, you can press the little plus. I've named it to move, and it's just a value and a vector 2. You can add bindings by clicking on the plus and add binding, or add an up, down, left and right composite if you need to use different keys for A and D. So the left stick is just the path for left stick. You can go to Gamepad and find left stick. The 2D composite is you want left and right, and you can listen on the keyboard and press the key that you want and add that. Jump is just a button, and that has a new binding of button south and a binding of space. Sprint is also a button, which is at the left shoulder on my gamepad in my case, and left shift on the keyboard. So now we have that set up. In my scene with my 2D controller, I'm just going to create an empty. I'm going to reference my player input handler that we created before, because we can add this between different controller types. But in this case, the action map should be just 2D player, in this case as an example, and you make sure that you add your player controls. You can open that back up. You won't need look anymore, so we can remove look, the look action, the look input. In the awake, remove the finding the look action, and then registering through the event, we can take off the look. Make sure we also take it from enabled and disabled. Just run down the script and get everything related to look, so we don't actually need it anymore. And also, we don't need anything to do with handling the rotation at this point. And then from there, what I'm going to do is choose a right click, C#, and I'm just going to name this my animated controller. And then I'm going to add that to my swordsman, and my swordsman's set up in a way where it's got a rigid body and it's got a capsule collider 2D, just so that it can take physics into account and we don't clip through other objects. I can add my animated controller here. I'm going to start by writing our controller script, very similarly how we did with the first person controller if you watch that. So we're going to have the movement speeds that we need. So I'll write serialize field private float as the move speed, set that equal to 5 as an example. You can adjust all these. Again, you can go serialize field private float sprint multiplier, set that equal to 1.5 F. Then we'll add something for the jump, which is a private float jump force. And then we're going to need a reference to our rigid body, which is a rigid body 2D, and we'll give it a shorthand of RB. Then we're going to have a reference to our player input handler, which is just lowercase player input handler, because we're going to then create a awake method to find these. So private void awake, then we'll say RB equals get component in angle brackets rigid body 2D. We find that, and I'll just make this input handler in lowercase just so it's consistent with my other script. So I'll say input handler equals player input handler dot instance. So then we're going to have an update method so we can start checking for some of the inputs that we need. At the top, I'm going to create a float for the horizontal input. And then in my update method, I'm going to say that the horizontal input is equal to the input handler dot move input dot x, because we only need to know where the character is moving at any time, whether it's left or right. So we're going to need to use the x-axis. Then we might want to check something for whether we should be jumping, to make sure that we check that and check the ground. And I'm just going to add something in this script to flip my sprite just when it comes to moving left or right, so it makes sure the sprite's looking the right way. Then because we're working with physics, we want to use void fixed update. This will help us keep this in a fixed interval to be able to update physics. I'm going to create a method called apply movement, and then to do with our jumping, because we need to make sure that we can control how the jumping works, and we need to make sure, because it's using the physics of the rigid body, we need to make sure it's fixed. That new method of apply movement float speed is equal to our move speed times by, and if you saw my other part of the tutorial, this is very similar. Input handler dot sprint value is greater than 0 question mark sprint multiplier colon 1f, and end that bracket. This just means that our speed will be equal to our movement speed, which is whatever it is by default, and then we'll look for the button or the sprint value, that button that we're pressing, and if the value is greater than 1 on our button press, we must be pressing a button, and if that's the case, we'll be sprinting. If not, we must not be pressing the button because it's less than 0, so then we'll be just doing our move speed times by 1, which will always be the same as move speed, because anything times by 1 is the exact same. Then to apply this to our rigid body, we'll say rigid body dot velocity equals new vector 2, and then we'll say horizontal input times by our speed, comma, rigid body dot velocity dot y, because we need to push the character in that direction. Now if we create another method called apply jump, in our case here, because we want to take the jump into account, we'll say that rb.add force, open brackets, vector2 dot up times by the jump force, comma, force mode 2d dot impulse, which just helps us apply the force to the rigid body. We'll say grounded equals false just for now, just so we know, and should jump will be equal to false as well, because we don't want to be able to jump again. Now we want a quick way to detect whether we're in a collision, to check whether we're grounded, because we don't have anything built in to check for this. So we'll write a new method called void on collision enter 2d. It's already filled out the parameters collision 2d, and then we'll say that if the collision dot gameobject dot compare tag is in open brackets quotes ground, where you can set these tags yourself, then we'll say that is grounded is equal to true. Now I'm going to quickly add a method just for flipping my sprite, just transforming the local scale to make sure that it works fine. And then we need to create ourselves a is grounded boolean right at the top. I'm just going to add is grounded, and I'm going to create another called should jump. So if we go back to where we were before to check for jumping, we'll say that to detect the input, we'll say that should jump is equal to input handler dot jump triggered and is grounded. For the horizontal input, we're just looking for the move input X, and for jumping, if the button's triggered, then we'll do it. And of course, for the sprinting, we look for it in times it by the move speed. In our method, which was the fixed update, we need to say that if should jump is equal to true at any point, we should apply the jump method. And now we can say that is grounded is equal to false, and should jump, which should be equal to false. And before we've got is grounded, so we know that we're on the ground, we can apply the jump and the force, and we've used our new inputs directly in here, referencing that input manager that we'd created above the player input. So we can go to the swordsman, and we make sure you add the animated controller script here. And one thing to mention, if you do get a sort of choppy looking character controller, you could change interpolate to actually interpolate, just to make it slightly more accurate. Make sure you have your player input handler game object with everything set up. And I will say, if you ever get any null reference exceptions about certain bits of the input not working, you can actually add your input handler reference finder into the start method, because sometimes Unity doesn't build fast enough, and when this gets created for its singleton, the player input handler, it sometimes doesn't create it fast enough. So if you put it in start, it will be after the original wake method, so then you will solve that issue. So now you'll see when I press play, I can move left, right, I can jump, and I can also pick up my controller, move left and right with my analog stick, jump with X, and then also sprint, so I can move faster when I hold my top button. So I can jump around and do everything that I want. And make sure to set the tags of your sprites just to make sure that you are grounded at any time, to make sure that you don't have any issues. And remember, it'll all be up on my Patreon to get this entire project, all the scripts and everything that you need to get yourself started. So I wanted to go into how to navigate UIs with a controller. Now I'm just using a mouse here, and it works normally by default when you add your own canvas. I'm trying to use my controller now, and it doesn't navigate anything. Now you might ask how we do this. If you think about it, when you right click and you choose UI and you choose to create yourself a new canvas, you will get an event system that goes along with it. Now, the event system was used originally to be used with the original legacy input system. You can see that the standalone input module is the old one and it needs to be replaced with the input system's UI module. Now, you can see here, if we click to replace it, as long as the input system is installed, we get a whole list of different actions that we can perform, whether that's point at left click, middle click, move, submit, and cancel. Now, if you see what the actions asset is currently linked to, it will be linked to one that's in your packages, that's the default one by Unity that they've created, which has just some basic stuff for player, and it's got some basic things for UI with everything set up with, you could see the navigate, you could see the submit button, cancel, and it's got everything set up as we would want. And you can look at these more deeply yourself. What we can do to make life easier is just right click and copy that action map from the Unity's default one that they created and go to our player controls option and right click on our action map area and just choose paste. And now we've pasted in an entire action map for UI already set up and ready to go. So as long as you've saved that out, you can go back to your event system and you can look for another actions asset, and I'm going to use player controls. And because we've added that UI, it will look for UI point, UI click, and of course you can choose between the different maps with what ones should be relevant to these if you so need to change them. But if we press play, it still wouldn't be able to navigate them, because here you can see that there's a button in the event system called FirstSelected, and you always need a button here when you open a new menu. So let's say this is our first scene here. We need to open up and I need to select the new game button, and I'm going to add that to the FirstSelected slot. You can see that I've set this highlight to when it's selected to blue. Now if I grab my controller and I navigate with my directional keys or my analog stick, I can move up and down however I want. And I'm just going to quickly make a mention about navigating buttons as well. And I do have a full main menu tutorial showing you the intricacies of navigation and setting up your menu, which I'll put in the description. So if we select this new game button, you'll see that it's on automatic by default, and you see on the visualize, you will visualize little yellow arrows in between, which will show you how it will navigate from moving up and down. So you can see the automatic new game will let you move to load game and back up again. Now, if you want to be more specific, you can set this to explicit and make sure you untick everything else. And then you can say from my main menu, what do you want to do when you select up? So realistically, we could add our exit button to the top. So you can see now this arrow knows that if we press up, we can go all the way down to the bottom because it's quite a nice UI feature. And if you select down, you could move to the load game and you can see that it connects that arrow. And if you move left and right, it doesn't need to do anything. So you can just leave those by default. And this just allows you to navigate them more easily. So you might ask me that when we select a button, how do we know when we switch to a new menu, whether we disable a panel and enable another one? How can we update this first selected box in code to make sure it happens? So I've just created a script called menu navigation, and I'm going to make sure that I am using Unity engine.EventSystems at the top, that namespace, and I'll just write this in a start method, and I'll say that the EventSystem.current.setSelected gameobject. And then we can specify just a new game object here, which is going to be the default selected button. And then I'll make sure that I save that out. And this is a way that you can apply every time you navigate to a new menu. And as I said, this is fully explained in my full main menu tutorial. So you can use this even in the new input system. I'm just going to add this to my event system. I'm going to choose my first selected object. This is just an example of what we can use. In this case, I'm just going to set it to the load game button. So even though we've got the new game button in the event system at the start, the script will override that. So when we press play, we expect to see the load game button highlighted on selected. So as you can see, the load button was selected because we specified that in script. Now we've got one problem which you might have noticed. Let's say we're navigating nicely with our UI, but because we're on PC, this is not so much a problem with console development because you'll only be using a controller. But let's say we can take control with our mouse and start selecting things. When we go back to our controller input, we can't actually do this anymore. But we set that new game button as the first one, but Unity forgets which one was the first selected in this case. So we can add a little bit of script to make sure that we can always navigate back if we use the controller again. So if I go back to my menu navigation script, I'm just going to write an update method to look if we've got a controller gamepad connected, and then we're going to update the button for ourselves. So in this case, if we go if gamepad.current is not equal to null, so we need to make sure that we've got a gamepad connected, and then we'll say gamepad.current.was updated this frame and EventSystem.current selected scene current selected game object is equal to null, then we'll make sure we close that off and then do exactly like we did above. We'll do the event selected and up to there. And make sure that if you were navigating your menu, you make sure you keep track of what page that you're on at any time, and you make sure you update both of these in your scripts. So now when we press play, we can see that we're on load game. You can see that I'm selecting and I'm navigating with my controller. Now if I grab my mouse, I can navigate and I can click, but I can navigate to other things. And now you can see if I let go of my mouse and start interacting with my gamepad, it will see that I can start on load game again. So we always remember where we were, just so that we make sure that we can use it again. So I think this is really important to know, and it's a lot of things that's not really covered. You can always comment down below if you've got any other suggestions to fine tune this, make it better, and share with everybody else, and make sure that they can get the best tips from you guys, because I know there's a million ways to do everything. I wanted to show everyone something very useful that not many people know exists, and now it's Unity samples for the input system. We will look at one of these in the tutorial, but these might help you out. So if you navigate to Window and Package Manager, and when you're on the Package Manager, if you go to Unity Registry, as if you were installing the input system, search for input, and you can see at the top you've got description, version history, dependencies, and samples. Click on the samples, and there's loads of different samples which have got various different demos that Unity have created themselves for you to be able to get different inputs. So you could use a gamepad as a mouse cursor, and that's got its own example. You can have in-game hints, an input recorder, on-screen controls, a rebinding, simple demo with a controller, simple multiplayer. You've got touchscreen samples, UI versus game input, Unity remote, and all you have to do is click to import one of these assets, and then it will be added to your samples for Unity input system for whichever version you're using, and it will have a demo scene. You may well need to upgrade materials if you're using a different version, like I'm using URP here. If we take a quick look at the UI hints demo, you can see that we have got examples. You can see the text in the corner. These are really, really basic demos. Really, some of them are a bit thrown together quite quickly, and it does have ways to show hints and stuff when you're using this system. These come fully with their own actions, so you can look at how they've been set up and the entirety of their own scripts, which will show you how these work in their examples. So we're going to take a look at the rebinding package by Unity in their samples. And like I said before, you go to Window, Package Manager, and if you make sure when you're on Package Manager, you go to Unity Registry, then make sure you search Input, go to the input system like you're going to install it. If you navigate to samples, you can go to their rebinding UI, and you can just choose to import that package. Then you will see it on the right hand side in your project panel under UI or rebinding UI. It'll come with a bunch of icons which are actually quite useful, because you could use those in other instances of your game, depending on the controller that you're choosing to use. And it comes with just the example scripts. It's got some readmes, and it even comes with save and load logic. It's got a rebound UI prefab, so you can add it to your own scene. It comes with its own example assets, so it's got some gameplay of just move, look, and interact. We'll open up the demo scene and I'll give you a look at it. It doesn't look particularly pretty, but as you can see here, it has the ability to rebind the controls. And this is a simple rebind, and we'll go through the look at how it's set up. So you've got move here, and you can select any of the actions. And from there, you can say what binding you want for the up axis. So I could use the directional arrows, and then for down is the down arrow, left arrow, right is the right arrow. So you can see it's up, down, left, right, because it understands which one. Interact on my keyboard could be F. And then on the gamepad, we could select something weird like the right analog stick for moving, left analog stick for looking. That would really confuse people. And then maybe an X on the Xbox gamepad to switch to that. And it does say in practice, you probably don't want to be able to let people remap the sticks, because that's going to really break things. And I just exited it and opened it again, and you can see that it saved my changes exactly what I had, and you can click reset if you need to go back to the originals. And you can see it's set up with a canvas, and on the canvas you've got gamepad and you've got keyboard. So let's go to the gamepad as an example. You can see them on this side. So we'll just look at the interact because that's easy to understand. The interact there, it's made up of an image and a rebound action UI, which they find which actual binding it should be based on which one you've got for that particular type. You could choose to omit it if you don't want it to be viewed, and then you could set the labels that they should be to each of the different prefabs. And then it's got a trigger and a reset button for each of the buttons, so you can click that the rebind action UI does the start interactive rebind. And if we go back to that object and we open up rebind action UI, and you can see here that the start interactive rebind finds the action and the binding index, searches through the different bindings that we have, and then will perform the interactive binding so that we can change what should happen. And you can see this, you could just duplicate the button if you wanted to create more, and you could just add that below if you have other actions. And because this action here, because this was from the gameplay action that we'd already created, and this does have other ones that I've got in this project, you could specify something like the gameplay drop if you had this available. You could select that, and you can change the binding depending on which one is specific, to say that if it's normally a gamepad B, you could see that it automatically fills in, and we'll be able to reset this and apply this to our scheme. And it does have saving and loading, and you can add this entire prefab into your scene to get a nice startup on using controller rebinding. And I also want to mention that Unity have got some brand new or a collection for URP, the starter asset character controllers, which are 2 sets of character controllers for Unity 2022 and above using Cinemachine and the new input package. And it's got a full starter package for a first person and a third person controller, full UI overlays for joysticks and touchscreens. It's got a playground scene and basic implementations of 2 controllers that you can use and look at how it's set up. And I'll leave the link to that in the description too. I do also have a couple of tutorials which are about remapping this basic third-person character controller and using your own player models, whether you use Cintiq assets or something else. You can retarget the animations really easily, and I'll put the links down below too. And after this long tutorial, if you stuck around with me, I want to say a big thank you for everybody for coming to watch, and do be sure to leave a like and a comment because it really helps me out, and leave any thoughts down below if you've got any improvements, anything that you could share with the community, because I always love to hear it. And do be sure to check out all the links below to check out all the savings across game dev and the new Unity sale. And do be sure to check out my Patreon, which will have every single one of these assets, all my projects, and all these scripts that we've created for today. Big thank you to all my patrons, special thank you to Peter Steiner and everybody else who comes to watch the video. So don't forget to like, comment and subscribe. Cheers.